So you've been handed your first script of R code, but it's like trying to read Klingon or Dothraki or a script from your GP. Just what on earth do all these words, numbers, and symbols mean? Well, in this tutorial, we're going to be having an introduction into what the symbols mean. That's right, we're looking at basic R syntax. Welcome to the Skullywag Lab. I'm Dr. Rex. In this set of tutorials, I'm presenting a bare bones introduction to the basic fundamentals of R coding. All those different symbols on your keyboard are used to some extent in R coding. And in this tutorial, I'll be breaking down what the most common use cases are for the vast majority of them. So that way, going forward, you'll be able to have a better idea about what the components of each sentence of code mean when you're looking at it. All right, let's start with the easiest, shall we? All the lines of code are run by either pressing this little run button at the top here or pressing Control Enter. Plus is for addition, minus is for subtraction, asterisk is for multiplication, and / is for division. Putting this into the script, 2 plus 2 gives us 4. 2 minus 2 returns 0. 2 times 2, 4. 2 divided by 2, 1. So very straightforward. Next up, the caret is the exponent. And just for completeness, I'll show you a square root. And this is done using a function. The first of these in these tutorials. For example, 2 to the power of 2 is 4. And the square root of 4 is 2. Next up, left angle bracket is less than. What I've done here is generate a vector of 20 random numbers between 1 and 100. Rex? Why, yes, my nerdy friend. What's a vector? Ah, sure. Well, we'll go over the dimensionality of different data formats in a later tutorial, but for now, just consider a vector to be a single row of data points. In this case, those data points are numbers. Typing the name of the object X prints the numbers into the console. If I want to know if there's any numbers in that vector that are less than 50, I type X left angle bracket 50. The answer is printed in logical values in the console, and this just means that there's just true or false values. That's what logicals are. This is obviously the same process for the right facing angle bracket. The equals sign is a little bit different in R. Aside from within function arguments and a few other places, equals is usually represented by 2 equals signs. So if we type the same command as the previous but use 2 equals signs instead, we can see that that final 20th value is reading as true, so that last value is 50. The reason why R uses 2 equals signs here is because sometimes you have less than an equal to or more than an equal to. And this format allows for that extra condition. So looking at X is less than or equal to 50, the values that are less than 50 are indicated here as true, but also that 20th value reads true as well because that is equal to 50. And this is the same for greater than or equal to. Now a single left-facing angular bracket followed by a dash is called the assignment operator. We use this to assign information to an object and store this in the environment for later use. For example, we assign the value of 2 to the object A, and this is now stored in the environment. The tilde represents approximation and is most often used in modeling. If you think about a classic regression formula such as y equals mx plus b, this is often written in the notation of y is a function of mx plus b or y is approximately mx plus b. In this context, the tilde separates the dependent variables to the left from the independent variables to the right. Next up, we have the backtick. This is usually used to mark out certain text as code, but the only time I've ever really made use of this is in R Markdown, which is a completely different kind of coding format. As you can see in this Markdown script, the sections of code are marked out with these backticks. The exclamation mark reverses logical arguments. Remember when we asked which numbers of our vector were less than 50, we get a list of logicals. Well, applying the exclamation mark outside of parentheses surrounding this command will reverse those logicals, giving us the opposite output. If you're wondering why this exists, it's most often used in writing functions. Okay, hash is a big one. This is the commenting symbol, and I use this all the time to annotate my scripts and make notes for anything relevant or important. What this does is it stops R from recognizing that text as code, so you can run the line of code in your script and R will ignore any lines beginning with a hash. Next we have the $sign. This is used to access variables. To show how this works, let's bring in some data. I open the stored data set of chicken weights. This has 71 observations across 2 variables. We can look over these variables by clicking on that little table icon on the right. Let's say I want to work with a weight variable. I return to my script and I type the name of the data set, followed by a $sign, followed then by the name of the variable we want. So the $sign basically means within this. And then that prints the values into the console. We can also store this data in the environment using the assignment operator, and that makes it easier for us to use it in later operations. Now there's a few commands that involve use of the percentage symbol. 2 percentages means the modulus or remainder. If we type 20% %6, that means that when 20 is divided by 6, there is a remainder of 2. A %/% is the integer division. If we use this again with 20 and 6, it tells us that 6 divides into 20 3 times. Another one is %in%, and this can be used to compare data or make quick queries for specific values. For example, if we want to know if there's a value of 50 somewhere in our data, we type 50% and the name of our data, and it tells us that there is. So all these commands using % symbols might have some uses in specific fields, but I've literally never used these. The AND symbol is, you guessed it, AND. This is used for a whole bunch of arguments in functions and elsewhere. The question mark is the query prompt. We can use this to find information on functions, packages, or stored data sets. For example, let's type $LM, which is the function for fitting a linear model, and this presents all the information on that function in the help box in the bottom right of RStudio. The underscore and full stop are mostly used to replace spaces. For example, R doesn't recognize an object name that has spaces in it, so we replace those with underscores or full stops. But uh-oh, you see how I added a space after that one and it still worked? Well, spaces are fine to use in R coding as long as they aren't sections of code that define specific terms like names or colors or other characters. In fact, you can often add spaces any way you like, and as many as you like, as long as those spaces don't break up any terms. The humble comma is mostly used to separate arguments in functions and also separating data points. Next, we have the quotation marks. These are used to name things, aka characters. They might also be known as strings. Yep. What are strings? Nah, no problem. Consider strings just a collection of characters or non-quantitative data points. Now, these might include numbers, but they're not actually used in numerical analysis. Think about letters or numbers that define group traits, but are not considered quantitatively. Things like maybe specimen numbers, for example. These kinds of numbers are considered textual characters and not actually numbers. So for cases like this, where we want numbers and letters to be treated as these character states, we put them within quotation marks. We also use the single quotation marks, usually for the same thing. The colon is called the sequence generator. This allows us to generate sequences between numbers. For example, we can generate a temporary list using the concatenate function consisting of 1, 2, 3, 4, 5. Notice how all values are separated by commas as well. Or we can just type 1:5 for the same thing. This can save tons of time and space. The double colon is sometimes used to access specific functions within packages as well. The semicolon is known as the command termination. This allows us to run multiple lines of code on a single line of script if we like. Next, we have the round brackets or parentheses. These are used obviously for PEMDAS and calculations, but also to contain function arguments. Now, if you don't recall what PEMDAS is, it's simply the order of mathematical operations: parentheses, exponentials, multiplication, division, addition, subtraction. Square brackets are usually used to index or extract specific values from your data. By typing these values within the square brackets, you can isolate them from the rest of the data set. I like to think of square brackets as those giant brackets that border matrices in maths books. You know those big square borders around numbers? And that's because square brackets in R are used exactly for that in most cases. They're used to contain sets of data points. Sure, they might have other uses in accessing lists and things, but you'll learn those as you go along. Finally, for the brackets, the curly brackets contain multiple expressions for a single argument. These are most often used in writing functions, so we're not going to worry too much about those for now. So we're going to have a little bit of fun now, and we're going to do a small exercise to demonstrate some of these tools. You remember earlier on I generated a vector of 20 random numbers between 1 and 100? Well, let's do that. Firstly, we're going to use the runIf function. Let's look at how this works using the query prompt. This opens up information about the function in the help window. If we scroll down to runIf, we see we need an n, a min, and a max to use this function. Scrolling down a bit more, we see that n is the number of observations we want, and min and max the lower and upper limits. So we run this line of code where we want to generate 20 random numbers between a minimum of 1 and a maximum of 100. All arguments used in the function are contained within parentheses and are separated by commas. And we'll save this in the environment as an object called x. Also notice within the function arguments, only one equal sign is used. Typing the name of the object will print the numbers. Let's round those off. We use the round function with our vector and digits equals 0 decimal places. Let's just use the same object name, which updates the saved information within that object. But when I made the vector for the earlier exercise, it didn't end here. I wanted the last number to be 50 to show how different commands responded. So let's do that as well. To do this, we type x, which is our object or our data, and we want to change a specific value, the 20th one. So we type 20 into the square brackets. Then to the value, we use the assignment operator to assign a value of 50. So if we now again type x and control enter, we see the last number is now 50. Now let's look at how the semicolon works. Because what this means is we can do all of these previous steps in a single line of code. And just like that. Nice one, mate. Finally, let's say I wanted to change a value within x to a qualitative character, or string of characters. Let's call the first value of the vector Skulliwag. To do this, we need to identify it as a string of characters using the quotation marks. If you print x in the console, you can now see it contains 20 characters, the first of which is Skulliwag. R doesn't allow numerical and qualitative data points in the same vector, so all of them have been changed to strings. So that's just a bit of an introduction to data manipulation. Here I've produced a cheat sheet of the syntax. Feel free to come back to this if you need to in the tutorials going forward. Finally, I should probably make it pretty clear here that these do not represent the sole use cases for all of these symbols. In fact, the use cases can be different across packages. For example, the plus symbol is used here in ggplot2 to make additional arguments in plots. But you'll learn these little things as you progress along your journey. Alright, that's it. That's your basic introduction to the R language. If you stick around for the next tutorial, I'll be introducing functions, packages, and the use of objects. If you found this tutorial useful, feel free to like and subscribe, and I will catch you in the next one.